watch out for the riders. Keep an eye out for the riders.
Trigonometric integrals. So we'll jump right into it. So when you have when you're given an integral with odd powers of sine x and cosine x. Okay, so let's do an example. I think this is the best way to illustrate and explain how to do these. So example will be integral of sine to the fifth x dx. Okay, so this, at first it looks kind of intimidating, but we can actually use the identities. So we have, let's see, we know that sine squared x plus cosine squared x equals 1, right? So we can rearrange this to say that sine squared x equals 1 minus cosine squared x, right? It's basically the same thing. So what we can do here with this sine x to the fifth is we can rewrite this as sine squared x to the second. So that would make sine to the fourth, basically, and then times the leftover sine x dx. Okay? So then we can take this sine squared x and plug in the 1 minus cosine squared x. Okay? So then we'll have 1 minus cosine squared x, all that squared, and then times the leftover sine x dx. Okay? And then from here on out, we could do u substitution. So we can make our u equal cosine x, and our du would be negative sine x dx. Okay? And then, as I said before, let's see. So now we can get dx by itself. So to make it simpler, so dx equals du over negative sine x. Okay? So now we'll do u sub. So next slide. All right. So we're before I go on to the next slide, I'll just show you here. I'm going to plug in a u for cosine x. Okay? And then we'll plug in the du for the dx. Okay? So what we actually get is integral 1 minus, and we had cosine squared, but now it'll be u squared, right? And all of that was squared. And then we have our leftover sine x from before. And for the dx spot, now we're plugging in a du over negative sine x, okay? Because that's what we solved in the last slide. So here again, the sine x's cancel. We're left with a negative, so that can come out in front. So we have a negative, and then we can multiply this out, just FOIL. So we actually get a 1 minus 2u squared plus u to the fourth, and then du. Okay? Alright, so then continuing from here, then we basically, okay, well, we all know how to integrate. So we're going to get a negative 1 over 5. I'm just going to, I like to write highest power first, so I'm going to rearrange it, plus a 2 over 3 u to the third minus u, and then plus c, because we're working with the indefinite integral here. And then the last step is to plug in our cosine x for u. Okay? So then we'll have negative 1 over 5 cosine to the fifth x plus 2 over 3 cosine to the third x minus cosine x, and then plus c. Alright? Okay, so the next thing I'd like to talk about is, so with sine, with like varying powers of sine and cosine and different combinations of them and whatnot, there is something called reduction formulas. So when you have a really high power, this is what you want to apply to it. So the reduction formulas for sine and cosine happen to be on page 419 of your book, of your textbook. And I don't want to take up your time like by writing them all out because they're kind of long. They're lengthy, but they're pretty simple to apply when you're given an integral to evaluate. So that's kind of self-explanatory. And there's also, I just want to mention, a table of trigonometric integrals. So of trig integrals on page 423, which you'll probably, I mean, I think there's a total of 25 formulas or something. So I highly doubt that you're expected to memorize all of them, but they'll be useful for solving homework problems. And also another thing, so some useful trig identities, and these aren't, I mean, I guess they're technically formulas, but you should be familiar with these by now anyways. So here's some useful ones. I just write them down to emphasize them. So sine squared x equals 1/2 times 1 minus cosine 2x. So these come from the double angle formula for cosine 2x. And then on the other hand, cosine squared x equals 1/2. And the same thing, except for now there's a plus in the middle here. Okay, so those are pretty easy to remember. And then we have sine 2x. So these 2's up here, those are powers. But this is within the angle. So the double angle equals 2 sine x cosine x. Okay, and then the double angle here, cosine 2x, equals cosine squared x minus sine squared x. Okay, so just keep those in mind. Jot them down or on your paper or something, just so they can come in handy in some problems.